Hi everybody. This video is about inscribed angles and central arcs. So I've already diagrammed this problem a little bit so you'll know what these vocabulary words mean. An inscribed angle, like angle T, starts from the edge of a circle. The central arc that goes along with that angle, to see the central arc, here's what you do. You look at the inscribed angle, T, and it hits the circle at points R and S. If you draw an arc from R to S, that's what we mean by the central arc that goes along with that inscribed angle. And the measure of a central arc, if you'll remember from a prior video, is the measure of this angle. Now, I drew these lines dotted because very often these will be left out of a problem because having all of these extra lines for angles can make the diagrams more complicated than they need to be. But remember, when we talk about the measure of this arc, we're really talking about the measure of this angle with the dotted lines. Now, long story short, here's a property that inscribed angles and central arcs have. You can look at it in one of two ways. An inscribed angle is half of its central arc, or the central arc is double the inscribed angle. And that's why in this particular problem, there's actually no work to show. Since we know the inscribed angle is 42 degrees, well, the central arc is double the inscribed angle. So it's 84 degrees. And you're done. That's it. Now, as you could probably guess, the diagrams can get a little bit more complicated than this. So let's do a couple more examples. And I want to leave the how-to guide on the screen, at least for the next problem. So here we have a quadrilateral that's inside of a circle. Now I'm going to take the opportunity to go ahead and tell you about a property. I don't think we're going to need it in this problem, but the opportunity presents itself. So anyway, if you can draw a four-sided shape, a quadrilateral, inside of a circle, it's called a cyclic quadrilateral. And cyclic quadrilaterals have an interesting property that normal quadrilaterals don't have, and that is opposite angles are supplementary. Now, if you don't remember the vocabulary word supplementary, supplementary means that they add to make 180 degrees. So I don't think we need this in this particular problem. I'm going to go ahead and use it though. Since I know that angle X is 92 degrees, then the angle that's across from it, angle L, I know that L and X have to add up to 180, so I know that angle L must be 180 minus 92, which I think is 88. So anyway, this is a fact to keep in mind. Occasionally it can be useful. But let's get back to our actual problem. So this problem is going to be really fast, I believe. Angle X, I'll color code it the same way. This is an inscribed angle. And we want to know part of an arc. So we want to know arc L to M. But the property that we learned in the previous problem tells us we need to start at this inscribed angle, X, and we go to where it hits the circle. So we have to connect K to M. So I know the measure of this central arc that's in red because the central arc is double the inscribed angle. So I'll take 92 and I'll multiply by 2. So this red arc is 92 times 2. That's 184 degrees. So I have this extra piece of information in this problem. I know from K to L is 90, that's stated. I want L to M, so I'm going to take the entire arc, which is 184 degrees, the measure of LM. The entire arc is 184 degrees. I'm going to subtract this part that I know, and that gives me the measure of LM. So what's 184 minus 90? That's 94 degrees. So LM is 94. Okay, let's do one more problem. And again, well, this time I'm going to clear the screen. So let's see what we have here. Now, a lot of times in these problems, I really suggest you get some colored pens or colored pencils and label these things pretty much like I'm doing. So we have a we have an inscribed angle here. I'll use the same color as before. And inscribed angles are related to their central arcs. So this angle at C hits the circle at X and Y. So we can say something about this central arc. The central arc is double the inscribed angle, so this arc must be 82 degrees. But look carefully. This central arc from X to Y, well, if we follow from X to Y along different lines, well, the point Z makes that same central arc. So this angle at Z must also be 41 degrees, because again, an inscribed angle is half of the central arc. Okay. What else? Now, notice I haven't even thought about the question mark yet. I've just been making marks and writing down things that I know. Eventually, I need to get to this question mark. It's a good strategy, though, in these problems to not focus in too much here. So, for example, if I wanted to immediately start finding this question mark right now, I might get stuck. I mean, I see this big triangle, but I only have one of the angles, so there's not an obvious equation that I can write down for the question mark. So let's look for any other information that we can. Now, here's another property about inscribed angles. You actually already know this. You just have to see it. Look carefully at point Y. Now, there's lots of angles that you could draw from point Y. The one I want to focus on is this one. Well, that angle hits the circle, let's follow the green lines, at X and Z. Well, the arc from X to Z, drawing these arcs is difficult on a writing tablet. That arc, well, that's half of a circle. The endpoints X and Z are on a diameter. Half of a circle is 180 degrees. And since inscribed angles are half of central arcs, half of 180 is 90. So that's a 90-degree angle. And now if you look at the triangle X, Y, Z, I know two of the angles. I know 41, I know 90. Since I know two of the angles, that means I can find the third one. So add 90 plus 41 and subtract from 180. So let's see, 90 plus 41 is 131. Subtract that from 180, since angles in a triangle add to 180. And I believe we'll get 49 degrees. So this angle, the question mark, is 49 degrees. So this is really common in these sorts of problems. They can get more complicated than this one, but you just have to jump around from where you're given information. I was given the 41-degree angle. That tells me about an arc. This arc tells me about an angle. Then I had to look at another angle. But realize that this really is just a numerical problem. There's no algebra here. There's no complicated equations to solve. It's just using this property about the relationship between inscribed angles and arcs. Anyway, that's the end of this video. Hope it helped.